Okay, 6.2, we're going to introduce the natural base e. Okay, e is like pi. It's just a number that comes up very commonly in science and finance examples. It has like some cool characteristics that we're not really going to go into, but just know it's a very cool number. Okay, it's an irrational number, meaning it goes on forever. It does not repeat. It can't be expressed as a fraction. It's like pi. It's just an unusual constant. Just know that it's about 2.7. Because when we graph it, that's going to be enough. Okay, so let's graph it. Even though we don't know exactly what it's going to look like, we can still get a good graph. So let's see. The e to the 0 is 1. So the y-intercept's still 0, 1. Okay, now if I plug in 1, e to the 1 is e. E is 2.7. So 2.7 to the 1 is about 2.7. So 1, I'm going to guess that that's about here. That's 1 comma e, which is about 2.7. Okay, if I plug in -1, what do I get? I get 1 over 2.7. I don't know what 1 over 2.7 is, but you know, it's somewhere low. So this is about 1 comma 1 over e. Okay, and that's enough to get my graph because I know it's still an exponential graph. It just has a base that is irrational. Okay, since if I go from left to right, it is getting higher, we call this exponential growth. Well, let's look at the next one. Let's graph it. So if I plug in 0, I still have e to the 0 as 1. Okay, now if I plug in 1, I get e to the -1, which is 1 over e. 1 over e is 1 over 2.7, which is something very low, lower than 1/2. So I don't know where it is, but it's somewhere over here. So 1 comma 1 over e. If I plug in a -1 here, the negative and the -1 cancel, so that becomes e to the 1. So at -1, it actually goes up to 2.7-ish. So at -1, I get e, or about 2.7. So in this case, it starts high and then it goes down low. I'm not crossing the x-axis because of that horizontal asymptote. So this is a model of exponential decay because it's starting high and going low. Okay, the reason this is an example of exponential decay is because I could rewrite this as 1 over e raised to the x power. And then because the base is less than 1, it's going to be a decay function, but they often write it like this. So the negative tells me it's a decay, but it's because the negative is making it a fraction. Okay, we're just going to review the exponent properties. They just have to, they're involving the base e, which while it's a number, we know we can treat it like a variable when we apply the exponent properties. This is not a trick. This is so we get used to them. So when we learn logarithms, we're very comfortable with the exponents. So these both have a base of e, so this is e. What do I do? Add the exponents, e to the 10th. Is that a good answer? We're going to leave it like that. I could put e to the 10th in the calculator and get like some kind of decimal, but that's not a better answer. This is a better answer because this is exactly what it is. Okay, let's add the exponents here too. So this is, what is this? 8 minus 3 is 5. E to the 5th, which is a good answer. Okay, what about if we add the exponents here? So -11 plus -2 is -13, which I did a good job on, but we normally don't leave our exponents negative, so let's rewrite this as 1 over e to the 13th. Okay, keep going. This is just exponents. Let's see, this is a fraction, so I'm dividing. Okay, if I do 24 divided by 4, that's 6. So let's just do 6 here. For the e, since I'm dividing, I subtract the exponent. So 7 minus 2 is 5. So this is 6 e to the 5. Let's try the next one. Okay, let's worry about the coefficients first. 33 divided by 11 is 3. And then I have e to the 4th over e to the 6th. I normally subtract the exponents. Okay, I can do this 2 ways. I'll do it one way and then I'll do it the other. If I do 4 minus 6, I get -2. So I could say this is 3 e to the -2, which is 3 over e to the 2nd, which is the correct answer. Okay, the other way I could do this is say, okay, 33 divided by 11 is 3. Good. If I subtract the exponents, there's actually more on the bottom. So the answer should be on the bottom. If I do 6 minus 4, I get 2, but they're at the bottom. So you could skip from here to here, or you could show the middle step. Okay, let's do one more. Okay, what about, 2 over 14. 2 doesn't divide by 14 very easily, but 14 divides by 2. 14 divided by 2 is 7. Okay, so this is one way I could do it is I could say it's 7, but it's at the bottom. And then if I do 13 minus 17, I get a negative number. Or I can say if I do 17 minus 13, I get 4, but it's at the bottom. So I could do it like this. This is one way to do it. The other way you could do this is you can say, let me simplify the 2 over 14. I'm going to divide them both by 2. So that goes down to 1/7. 13 minus 17 is -4. And then once I get this, I know the e to the -4 goes to the bottom, and then I end up with this answer down here. So you can skip to this step, you could do this step. It's going to be up to you how you want to do it. Okay, let's see, what are we doing now? Now we're raising this to the second power. So I need you to apply the second to everything. So I'm going to distribute the second power. You could do it in your head if you would like, or you can do it on paper. So I'm going to distribute the second to the 7, e to the, and then when I have an exponent to an exponent, I multiply them. So 5 times 2 is 10. So my answer should be 49 e to the 10th. I could also write this out 2 times. Okay, your work can be different as long as I know how you did it. Let's try the next one. Okay, so if I distribute the 5th power to the 2, I get 32. And you can skip straight there. E to the, and then since I have an exponent with it times an exponent, I multiply them. 7x times 5, that's 35x, which is a little weird, but we're going to go with it. So I get 32 e to the 35x. And I'm okay if you skip to the answer as long as you remember to distribute your exponent to the constant or the coefficient. So what is this? This is 4 to the 3rd. E to the, if I do -2x times 3, I get -6x. So I get 64 e to the -6x. No, I'm not okay with that negative exponent. So 64, I'm going to move the e to the bottom so I can make it a positive 6x. And I don't know what x is, but this is still a better answer. Okay, the next one, same rules. They just look a little bit weird. So these all have a base of e, which is great. Okay, I'm going to add up all the exponents. So 2x plus 5 plus 7x. Okay, but the like term, 2x and 7x are like terms. So that's going to be 9x. But I still got to add that extra 5. So it's 9x plus 5. And even though it looks weird, we're going to leave it like that. Okay, we're multiplying. They all have a base of e, so let's add up the exponents. But they're like terms. So this is x and x. That's 2x. And then I have the -4 and the 13. -4 plus 13 is 9. So e to the 2x plus 9. Okay, one more. Okay, we're dividing, so I'm going to subtract the exponents. So what do I do? If I do 5x minus 2x, I get 3x. Now be careful in the next part. If I do 7 minus -4, 7 minus -4, I get 7 plus 4, which is 11. So I have a 3x and I have a positive 11. And even though it looks weird, that's my final answer. Okay, and now we're going to look at this last exponential model. And they're going to look weird, but we're going to be okay with them. Okay, it says you and your friend each have accounts that earn annual interest compounded continuously. And if you don't know what any of that means, it's okay. The balance A in dollars of your account after T years can be modeled by this equation. Okay, what do I care about? I care that the balance A is dollars. I count that there's this T years. That's mostly what I care about. The graph shows the balance of your friend's accounts. This is my friend's. Which has a greater principal and which has a greater balance after 10 years. Okay, so we're comparing us with our friends. Okay, let's start with principal. Okay, when you're talking money, principal is the starting amount. So how much did I start with in my account? Or how much did, whatever it started with. Okay, so we got you and we got your friend. Let's do your friend first because your friend has a graph and your friend's easier to read. Okay, so I started this graph right here at 4,000. So my friend started at $4,000. What did we start with? Let's look at our equation right here. We have 4,500 times e to the 0.042. We started with 4,500. Whatever's in the front is how much we started with. Okay, so who has, which has greater principal? You have greater principal. You have greater principal. Or it means you started with more money than your friend. You started with 4,500, your friend started with 4,000. So you started with more. Okay, now they want to know who has a greater balance after 10 years. So now I got to plug 10 years in. 10 years is going to be, it says T years. So I want to know at T equals 10. at t equals 10, who has more money? Okay, so for me, or you, I don't know if it's me or you. Okay, I'm going to plug it in the equation. It says A equals 4,500 e to the 0.04 times 10. And we're going to try to put this in our calculator. You're going to try to find your e button. It normally has e to the x on it. Okay, and you might have to point the 0.04 in parentheses. We're going to play with it. Okay, my answer should be 6713. I'm going to do 2 decimals because I know this is money. So you have $6,713.21 after 10 years. Okay, now what about your friend? Well, your friend is looking at the graph. So at 10, what does your friend have? So at time 10, this is time 10 right here. Let's see what your friend has. Your friend has, ooh, I think your friend's got more. Because what is this? This is 6,000, 7,000, 8,000. Your friend has more than 10,000. Has more, was it 10,000? No, more than $7,000. Okay, so at, who has a greater balance after 10 years? So after 10 years, your friend has a greater balance.